All right. Hey guys, I had another spontaneous idea, and that's why I'm doing this live stream. Because this guy just kind of wandered into my lap, and I'm gonna do my very best to try and figure out what's going on with it. And I figured this would be an excellent time to walk you guys through some things. Like, hey, Life Delight, how's it going? You always seem to be next to a computer. So anyway, I've got a medical grade isolating transformer here, which is not the same thing as an isolation transformer, which I have right here under my desk. And if I can solve this problem, I'll compare the two of them right next to one another. This one is just in such a nice little case. I want to turn this into a true isolating transformer. That would be my goal. Cool thing about this guy is it's got these removable cords. You can get short ones, you can get long ones. They've got the male IEC connector to a regular plug. So it just plugs onto the back. I'll show you guys what I'm doing here. So you can see, just plugs into the back. I've got it up here just for demonstration purposes because it wants to wander off on me. So I just got it, I just plugged it in, and I didn't hear any fancy noises. You hear that? In fact, I might hear a little bit of odd noises from that switch. So you guys are exactly where I am on this. I just walked up to it. I realized normally when you flick the power on a transformer, you're going to hear the coil saturate. So it's going to go like dunk. You'll hear it. And I didn't hear nothing. So I am naturally going to assume that I have 0 volts on this guy. See if I can get a good. All right, so there's my meter. It's on AC. Let's see what we got. And that is a big fat nothing, huh? Nope. So where do we go from here? First thing we always do is your fuses. Let's check this out. I'm going to put my meter over on continuity. And let's see. Uh-oh. Okay, so my meter's good, which means that this one here is not good. So 1 blown fuse. Okay, and 1 good fuse. All right. Hey, dog. At least I got somebody joining me here. So we got 1 good fuse and 1 bad fuse. Well, if you guys have been paying attention when I talk about fuses always pop for a reason. So if I were to replace a fuse, it's going to pop another one, guaranteed. So I'm going to go ahead and take the bad one. I'm going to throw it away. So I'm only keeping the good fuse on my desk along with the fuse holder. And we're going to have to open this guy up and take a look, see what we got. This is going to be a real fun one too. Hold on just 1 second, guys. Hey, Patty. What you doing, big girl? What you doing? Hey, come on. I want you to go outside, okay? I can't have you here. Come on. 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 Let's go. Hey, come on. Come on. Let's go. Come on. Good girl. Thank you. Oh, bulldog. All right. Sorry, guys. My bulldog is She's very loud, and she's such a pain in the butt, as all bulldogs are. So, all right, let me pull this guy out. So you can see that this is a medical grade transformer, and it is sealed with aluminum pop rivets. You see that? So we only got one thing to do. We got to drill out all the perimeter pop rivets. And in order to do that, use this guy. I already know that somebody's going to say, hey, why are you using an impact driver to drill? Because I can, man. I already know it. I always get these odd comments. So all I'm trying to do is remove the very head. There you go. So as soon as it starts spinning like that, it's aluminum, it's super soft. As soon as it starts spinning, then it just comes right off. And you don't even damage the metal. So you just keep hitting it very lightly until it starts spinning. And then you lift off your driver and you're good. All right. I'm going to have aluminum all over this mat. There it goes. Not even damaging the paint. These are very sharp. That's why I'm using a tool. This thing's very heavy too. So normally these type of power supplies, we find them on the bottom of audio video carts, you know, endo carts, all sorts of stuff like that. There we go. Jay, thank you very much for your comments, man. I appreciate that. I cannot believe how much support I've gotten for my videos across the Biomed community. I'm so humbled by it, to be honest. There we go. I'm being very careful collecting all my aluminum because there's nothing worse than getting aluminum in your arms. Notice how I'm keeping the RPMs really low. There's no need to go super fast and throw aluminum all over your desktop. Just keep the speed nice and slow. It's aluminum. It's really soft. It'll cut very easily. Well, thanks, Matt. I appreciate that. You know, I never know what I'm going to work on, and neither do any of my associates that I work with. I like to, you know, my day, I can go from working on a hydraulic surgical table to working on a microscope, like in minutes. Or I'll have a freezer the next moment that is, you know, in the state of an emergency because they have hundreds of thousands of dollars worth of contents inside that are going bad. I really honestly never know what I'm going to work on. And that's why my videos are so chaotic. I think. So I had one person that somebody that I actually admire. He's an instructor over at BAMC, which is you know, the Department of Defense Biomed School. Well, anyway, he came up to me during the MD Expo and he said that your videos are so raw. And yeah, that's my style. They're raw. Life is raw, you know? We don't have to make this stuff look pretty. Trust me, if I mess something up, you're going to see it. I mean, that's how it is. All right. Oop, almost. There it is. So one of the problems that most people have when they get out a drill is they just hammer down and they drill the hell out of something. And you can see I can replace all these pop rivets, and this guy is going to look factory new when I'm done. Right. Since the main basis of this guy is going to be this giant transformer, unless the transformer is bad, which is kind of rare, it's going to be something stupid that's causing these fuses to pop. We're going to figure that out in just a minute. Last one. All right, that one wanted to twist on me a little bit. When that happens, just give it a little bit of pressure and hammer down just really quick, and it will usually break the chip that's making the pop rivet spin. All right, so next thing next, you make sure I keep all the contamination in one spot. So I'm gonna quickly vacuum this. Gotta love battery-powered vacuums, guys. All right, let's do it. And this, I'm gonna just take a Phillips and something to bop it with. How about this? 250 watt resistor. Just nice and easy. There you go. Now all these studs that are popping off on the inside, we got to find all those, because the last thing we want is loose aluminum chunks flopping around inside a 120 volt transformer. All right. There we go. That should be it. All right. Oh, wow. This is a nice one, too. Look at this. All right. Let me disconnect this ground. You guys are probably wondering why I'm not using a regular socket to get this guy out, to which I have no answer. I can tell you, that's a long ground stud. There we go. All right, this guy has got a very interesting circuit card on the inside. And it is sharp in here. Hey, Bjorn, how's it going, man? All right, there we go. All right, let me get all these studs out of here. Okay. All right, let's see. I think that's all of them. All right. Okay, so what do we have here? All right, so these are the primaries. Let me get some angle cutters. There we go. Okay. So these right here are the secondaries. Okay, so I got LN and U. Ground. Okay, so I can see what's going on. So we have electricity comes in from your IEC outlet or your IEC power input module, comes into the circuit card, and it goes through a power monitoring circuit. It's got a relay, it's got a mini transformer, and the mini transformer, hold on, let me just pull it out so that y'all can see it. It'll be way easier to explain it that way. Let's see. Because we have to take this apart anyway in order to troubleshoot what's really causing the problem. Now, if the problem is the transformer, then this is basically junk. I doubt it's the transformer. BJ, saludos. Okay, here you go. Now you can see the card that I'm talking about. So here's your input, and these are the primaries right here. So what happens is the power comes into here, and it monitors it, and it actually strips it. It rectifies it, and it comes over here as DC, so that it can monitor it, and I would assume to kill the power. Maybe if it's an overcurrent or something, it monitors it. These over here, those shouldn't be diodes. These here should all be, they say 3033. So this should be the bridge rectifier. And then all these right here would be current monitoring, I would assume. I don't know. I'll have to read up what those components are. So anyway, it comes in here, and the transformer is a step-down transformer, 120 volts. Probably brings it down to about 5 volts, I would assume, because I don't see any buck converters in here that would, limit the amount of voltage. So this is probably it steps it probably way down. Yeah, I can see the inscription here. So AC comes in on this side of your bridge rectifier, and then on this side it exits out as DC, and then it cuts over these guys right here, which they can't be current monitoring. I don't know what these are. I'll have to read up on that. But anyway, your DC bus comes out on this side, on the back side of this, comes over here, and this is where it monitors it. So basically, I've got a short. And in order to troubleshoot this guy, there's a couple different ways of doing it. One way would be to, I would assume it's probably this board that's bad. So what I would do is unplug my primaries from the card. It's this one and this one. And I don't know if you guys are in the habit of doing this. Whenever you take wires out of holders, take a photo of them. All right. So this card is completely standalone at this moment. Now, if I change out the fuse in here and I power this guy up and it does not pop the fuse, then we know we're good. Okay, so I should see on these two right here 120 volts, and it should be constant and steady. So that's what we're going to test right now. I'm going to go ahead and change out the fuse with another known good fuse, and we are going to give this guy a shot. So here's two fuses. Let's see, what are my amperage? That's 6.3 amps for that one. 6.3 for that one. Shit, we should be good. Let me check them real quick with the meter. All right, before you cut yourself a hole when troubleshooting, always check your stupid fuses, man. I think we have all been burned by this little concept right here. Okay. Okay, that one's good. That one's good. All right, so at this point, we should have 120 volts on these. As soon as I change this guy out. That power switch almost feels a little grainy. Okay, I'm not really sure about it. We'll have to go with faith on this one. Uh-oh. Is that my problem? I don't think the camera can pick it up, but this wire right here, this connection is right next to ground. You can see how it's bent over right there. Wow, that is super close to ground. Let's try these, see if I can bend it straight. I don't know if that's the problem, but we're going to go with no, that's not the problem. We're just going to continue down the road that we're on. But it was right next to it, so who knows? Okay, so this is another good reason to be using one of these mats, because you can test live electricity. You don't have to worry about it too much. And that is what I'm going to do right now. Let's put it on bolts. Let me set it up so that y'all can see it. Startup delay board. You know something? Yes, this one is a startup delay, but also because this guy here has got, it's definitely got some filtering going on. You can see I got a giant mauve right there, it looks like. Or is that an inrush limiter? Usually the blue are metal oxide varistors. I'll have to see if one leg's connected to the ground plane. But anyway, let's pop this guy back down. Let's take a look. There's my power cord. What did I do with my power cord, guys? All right. Always got plenty of power cords. Who cares? All right, because I don't know what's going to happen to this guy. I'm going to go ahead and plug it into this guy first, and then plug it into the wall, because we don't know where that short is at. All right. So all this right here is dead. It's not connected to anything. Here's your secondaries. Here's your primaries. So right now, if I hit power, then the power is going to go to this guy, and it's going to monitor the power. And if it's within whatever range it's looking for, that's when it's going to click this guy over, and that's going to give me my primaries right here. All right. And it's going to happen almost instantaneously. So let's see. Okay. This immediately clicked over. So I should have 120 volts right now on my secondaries. Wow, that was quick, guys. That was quick. So it clicked it over, and then almost immediately it popped the fuse. I've got nothing on my AC input and nothing over here on this side. That's good. That's really good, because that means my transformer is absolutely fine, or is probably fine. I could, you know, measure it out real quick with ohms. Fine. Here, let's go select. All right, we're on auto ranging for ohms. We're checking the primaries. Oh, look at that. That's beautiful. Okay, and let's check the secondaries. Now, the secondaries have all these receptacles connected, so it might show a little bit higher resistance. Look at that. My transformer is probably just fine. So it's this board. The reason I said that that's a really, really good thing, guys, is because what I can do is I can almost literally take these two right here and connect them straight to this. Now, I'm not talking about putting this guy back in service as a medical grade thing. What I'm going to use this guy for is a desktop isolating power supply. Because look at the form factor. It's beautiful. It's got all these different outlets right here, so I can plug in different devices. Now, this would be when I'm done with it, it'd be a true isolation transformer. I'll have to measure it just to be sure. But I think okay. Here we go. Okay, so for a true isolation transformer, I should not have any continuity whatsoever between my primaries and secondaries, okay? See that? My meter is saying, hey, I got nothing, man. That's excellent. So what I would end up doing is if I want to see this on my workbench, which this is much better than, you know, my traditional isolation transformer that I showed you guys. I mean, look at all these receptacles and options I have. So what I could do is I can wire these guys right to these guys, and I will have true isolation power here. And I would technically be done. But that's not what I'm here for, right? I'm here because this bad boy, this guy right here, has got something wrong with it. So I'm very excited about that. That means that I can wire this guy up, I can put it on a workbench, and I actually feel a wee bit safer about using this guy on my Biomed 1. If you guys didn't know, I've got a Biomed 1 that's working with me right now, and I'm training her, and I want her to get into this kind of stuff. You know, I want her to be opening stuff up on her workbench, and I just don't want her to have a lot of the same bad situations that I had, because I have been electrocuted several times in my career, usually when I'm working on power supplies. So I'm going to go ahead and set this guy down. He's a champ. All right, and let's take a look at this board right here. I'm going to get this guy out of there. Wow, you guys can probably hear my phones and everything are just going nuts this afternoon. Horseman 12, I'm starting my Biomed internship in a couple weeks, and I'm worried since our instructors really only taught us electricity basics rather than a lot of troubleshooting with hands-on equipment. Horseman, that is a good point. And that is why I am doing this right now. Because you guys have to learn the process. And I really wish that Biomeds had more like a journeyman system, because you sit there and you watch somebody else's process and you don't get yourself killed and you don't kill anybody else. I mean, that's the thing. I'm not trying to worry you or anything, but I really wish we had this process down a little bit better as a career field. I mean, since we don't have like a real licensure or anything, you would just expect this kind of stuff. So this guy right here has a miniature power supply on it, right? Yeah, oh, I see what's going on. Wow, that's weird. Okay, so I have AC input on this guy, and this guy here, this little green thing, is actually a DC power supply. So that means it's got some sort of rectification inside it to turn AC into DC. And let's see, do I see any brown spots or anything under it? Looks pretty good. Componentry, you can read it, and it says that it is a DC power supply, which is pretty crazy. So there's two steps of rectification. There's this one, and then there's this one. I don't know why, but whatever. You see all these PTCs right here? I wonder if those guys are what are bad. They don't look like they're in too good a condition. You see that? So one of the things that I'm noticing is normally power supplies are bad, but what happened is it energized this guy right here, and then it de-energized it almost instantaneously when it popped that that fuse. So that's telling me that it's someplace on the output side of this guy right here. And the only thing that's really on the output side are these PTCs right here. The part number for these are PTC B as in Bravo 750, 750s. In some place, I have a short. All right. Well, what they say, take it apart. Ooh. So you guys are seeing step by step my troubleshooting as I do it myself. You know, you guys know all biomeds do their own thing differently. This is how I work. So if I was someplace else and I really need to fix this thing, then what I would have to do is go to the output side of this guy right here, this relay, and check probably for continuity between the 2 points. And let's see what we get, huh? Do we have any ohms? Whew. Of course, if there's a short, all these guys are going to show the same. Well, guys, if I didn't know any better, I would swear that those PTCs are shorted, like one of them is. And the only way to find out which one is to take them out of circuit, you know? I'd have to desolder them. Bjorn, that is not a good idea. We call that chasing smoke, and you're actually correct. That is definitely one way to do it. You wrap a fuse in aluminum foil, you stick it in there, you keep one hand on the power button, you flick it on real quick, and then you see which item gets hot. And if you have an infrared thermal imager, you can do it much, much better. So you just get your thermal infrared imager, you put it over it, you flick it on real quick, and you watch which one heats up the most. And that is an actual troubleshooting technique. It's just, oh my God, it's so not a good idea. So yeah, it's going to be probably one of these PTCs. I think those are the output side of this line. Or are they? Neutral. So neutral comes down this leg right here. And this side here is actually connected to hot. So half of these PTCs are connected to hot. And then the other half is connected to whatever. Well, shoot, guys, without really completely destroying this board, I think I'm not going to do that. Because that board does not matter to me at all. What I care about is this guy. All right, so let's see. We have primaries, secondaries. So it doesn't matter what your polarity is, obviously. It doesn't matter. It's not going to matter at all because it's an isolation transformer, and you should have 60 volts on each leg on the output side. So unlike hot and neutral from, you know, anything else, this one here is not going to matter at all. So I could put both of these together, which I'm going to do because why not? All right, so let's see. I'm going to go ahead and clip these guys off. These are wire fair rules. Here we go. So if you guys ever reach wire fair rules that you want to change out, you see what I'm doing. I'm clipping it right here, right above the plastic. And they tend to shoot across the room. That's why I'm being careful. And then you just pull it right off. Super simple. Okay. So I'm going to strip these guys back, and I'm going to wire nut them together. And we are going to go ahead and give it a shot, see what happens. Okay, there's those. All right, these ones have like a fiberglass coating down the sheath, so I'm going to strip them right before that. Here we go. Excellent. All right. Bjorn, you're right and wrong. I have enough other devices connected to this circuit that it shouldn't inrush too badly, because if you guys don't know, components all have like a certain level of capacitance, and they all kind of help even out the system. I could booger up my computer, which I think is plugged in over there, hopefully not on this circuit. If I go off air, you guys know what happened. All right, so let's pop this guy out. Let's change out this fuse one more time. All right, let's see which one's boogered up. Oop. Holy cow, both fuses are good, guys. Both fuses are good. Who cares? Let's put them back in. Let's put them back in. Like I said, that power button was a little sketchy, but I think it's going to work for my purposes. Okay, so let's see. We got this here. Let me get my output plug. All right. So this is going to be my output. And if I go off air, you guys know that there's something else going on, okay? All right. All right, and my power cord. Where do I keep putting these stupid power cords? Okay, y'all ready? We're live, and well, there's a little bit of dimming on the lights. You see that? And guys, that was one and done. Do you think I boogered up the fuse? Let's take a look. Could it be that there's really something wrong with this transformer? I'd be so upset. Oh, gotta have it on the right mode, guys. Oh, screw it. All right. So there's something going on. So yeah, let's take these guys back apart. It's either that or the inrush just fuse. My lights actually did dim for a split second. .9 of an ohm, 1 ohm. This one's a challenge, guys. Jeez. I thought this one was going to be a wee bit simpler. Now, I do hear a little bit of grime on this power switch, and I hope that that is not what's popping my fuses. You know, because if it's got something inside the power switch or something. Oh man. Anyway, that's almost upsetting. It popped it pretty quick. And these guys here are soldered on, so I would have to cut the wires in order to test the secondaries. Why not, right? It's already broke. Okay, I've got 0.4 of an ohm on the secondaries. I have no signs of it overheating or anything, so I would normally assume that that is normal. Who knows, guys? Who absolutely knows? You know, gosh darn it, that really upsets me too, because it's such a perfect form factor, size-wise, for sitting on a bench, and this guy is just upsetting me. What I need to do is I need to put it in series and monitor the current and see what's really going on. But boogered, straight boogered, guys. You win some, you lose some. Anyway, I honestly don't even know what to say. I was hoping to get a brand new isolation transformer, to which I have this one. But as you can see, this one is just not as pretty. So normally I would put, this on my workbench whenever I'm tearing something apart. But if I put this one on the workbench, people just look at me like I'm weird, like what the hell's going on over there? So this is almost the exact same thing. This is an isolation toroidal transformer that came out of one of these type of devices. And instead of throwing it away where it was on its way to go in the trash, I pulled it out of the trash because I knew what it was as soon as I seen it. And then I ended up putting a power strip on it. So this guy here can sit under my desk, and this guy here is all that you see above the desk, And whenever you're testing a AC device, whenever it's open, it's always safer to have it plugged in to this guy, because that way there you are not part of the circuit, and you're very much not likely to get shocked. So that's the whole concept behind this. I'm not completely giving up on this guy. I'm gonna have to dig a little bit deeper, see what's going on. The transformer itself seems like it's absolutely fine. I'm kind of cross between maybe the inrush current is popping the fuse, because those fuses were only 6.3 amps, guys. That is not very much when you're talking inrush. That's not much at all, in fact. So maybe I'll do what Bjorn says. I'll get some tomorrow at work, some little like 10 amp or 12 amp. I'll get some 10 or 12 amp fuses and throw in there and see what really happens. But goodness. Anyway, I wish I could have fixed it for you guys, but it is what it is, man. Anyway, I do have some other cool stuff to share with you guys. Oh my gosh. These transformers are just so crazy heavy. So I used to do a lot of custom radios. I used to do a lot of woodwork for people. And if you guys didn't know, I've been working for a while on getting a logo designed, like a really nice one. And the logo I wanted was a snake wrapped around a wrench. It's a play on the medical symbol, And the first one that she gave me was this one right here. So the first one she gave me was a cobra wrapped around a pipe wrench or an adjustable wrench. And I was like, that's the wrong type of wrench. I wanted a double-ended, open-ended wrench. And she sent this one to me. But it looks so cool that even though it's not applicable to me, I'm machining it to be the inside of a radio, because I used to do custom radios back in the day. And I'll probably post some pictures maybe in the community section of some of the stuff I used to do. I used to do a lot of woodwork, and apparently, I've got all this stuff here where I still could do that kind of stuff. And I don't know. I haven't had time, probably because this takes up so much time. It really does, guys. And I would rather be making videos, I think, than doing woodwork. But I want to get back to my roots, and I want to make another radio. It's going to be a little Bluetooth set, and just a little guy, you know, maybe about this big, that sits on my workbench. So anyway, that's what I'm currently working on. It's going to be real cool when I'm done. I'll maybe post some photos. And man, I've got a whole series of videos that I have yet to do. I have some parts that are being shipped in from China to fix this guy right here. This is the circuit board to the Skytron surgical table. And I was able to find the fuses, which is this guy right here. That's a F2. That's a 1.6 amp, really tiny fuse. It's designed to pop. But anyway, the guy that is hard to get is this guy right here. It's a tiny little solid state relay. You can see a bunch of them all over this board. They're very difficult to get. And I am getting them shipped in from China because the Chinese are exceptional at recycling components or, you know, handling components. They even make their own versions of components. These ones here, they're TLP 202 alpha. So they're very hard to get. And I was just going to change out the fuse and put it in the table and see maybe that solid state relay isn't as bad as I thought. But I already ordered them, so it's on hold. But I'm going to do a video on me repairing this when it happens, because some of the stuff like the solid state that's in here in between all the components, that is not going to be that fun to get at. So hopefully my quick hot air station, which is an exceptional hot air station, hopefully it gets it up to temperature really nice. I'm going to have to do things like preheat the board because, you know, there's several different layers on this board, and you have to preheat the board so that you're not expanding and contracting one little piece. You want to kind of heat up the whole board at once. So it's going to be a little bit of a project, but this is going to save me about $1,500 just fixing this board with one little fuse and one little solid state relay. And I'm going to have the fuses and the solid state relays here. And I'm thinking of maybe showing people how to fix things and then incorporating the parts to fix them and maybe selling them here, because the parts are really hard to get, okay? And since I've already done the research to find them, you know, I could package like 2 fuses and 2 of the solid states, one for practice, obviously, and one to actually fix your board. But, you know, sell it for like 30-40 bucks for the repair kit, you know, because that's, you know, between the bother and how much it's costing me, that's what it's going to be. Oh boy, do I have some videos that I'm going to be coming out with. Got some 5-watt resistors. Here are the replacement fuses. These guys right here. And in Houston here, we have an excellent electronics place. Unfortunately, they don't have surface mount components. I kind of understand why they don't have too much of that, but it'd be nice if they did. And they have everything that I could think of, everything. They even have some of those Bakelite rotary dials, like I'm talking 30, 40 years ago, the old dials and the rotary encoders and stuff from way back. They still have that stuff. They have some of the old wiring harnesses and stuff that they used to use back in the day. And man, Bjorn, you're asking for a video about limbs. Yes. In fact, I just found another line isolation monitor tester, an older one. I had one here. I had one here that I tore apart on video, but I found another one, an older one, and it looks like it's in excellent condition. So I have 2 brand new ones from Bender, and I have one older one, and it would be really neat to compare and contrast the technology between them because it is different for sure. The older one looks like it's a little bit easier to use, but the newer one has so many more options for testing, like, you know, L1 to ground, L2 to ground. You know, you can fine tune everything. It's like a calibration device for calibrating your limb display. So it's a very cool setup, and I do want to do a video on those. I need to have some time. I'm on call this week, So maybe if I get called in between, I don't know, today, tomorrow, knock on wood, I hope I don't. But if I get called in the middle of the night, then I would probably take one of those guys down and use it on a line isolation room and see how well it does its job. You know, that would be really cool. I'd love to film that. But you're interested in measuring the signal on a scope. What signal would you want to see? You want to see like you want to see the output from the secondaries, like what we have coming out of the receptacle? Is that what you want to see? Because hospitals have excellent line isolation systems. The transformers are second to none. I mean, the quality. So you're getting almost exactly 60 volts on each of the legs. So unlike some places, like even this system that I have here, I will get like 52 volts on one and 65 volts on the other, or something like that, you know, because they're not completely symmetrical on their windings. But the ones that they use in the hospital are like beautiful. They have almost a perfect 60 or 62 volts on each of the legs. It's wonderful. So the signal, what the limb use. Bjorn, have you seen my video on isolated power systems? Because I kind of do a breakdown of what the limb monitor looks like and what it kind of is looking for. The high frequency signal on top of the mains. What do you mean the high frequency signal on top of the mains? We're at 60 hertz. I'll record the whole thing so that you can see what it looks like. It's quite the thing. The new ones from Bender, those ones are very complex, and they've got different dials that you can set. And yes, it's got a digital readout for your leakage and whatnot. So I'll do a video for it. I'm not asking to get called in, but if I do get called in, I will have no problem throwing on my scrubs, taking it down to one of our, you know, isolated power operating rooms, plugging it in and just giving it a hot supper. You know, I have no problem whatsoever. A limb superimposes a low voltage, high frequency signal. No, not in hospitals. No, sir. The reason they can't do that is because medical equipment has a 60 hertz filter, like a notch filter, just built into them. And we can't have any random high frequencies in operating rooms because they're doing things like EEG monitoring, and any of those extra signals are considered noise. And so trust me, I'll put it on the oscilloscope and I'll show you. It's perfect. It's perfect 60 hertz sine wave on each leg, and there is no high frequency signals like a carrier frequency. There's no high frequency for monitoring. If you haven't seen my video on isolated power systems, I show you almost exactly how it monitors for how we do it. Now, I have no idea how Europe does it, but for us and for almost every hospital that I've ever been at, they use an active system. Active, which means it's always on. They do have passive systems or standby systems, which is it's on regular power, but when it senses a single fault condition, then it will flip over. It's got like an auto transfer switch, which will flip over, and then you go off of your isolating transformer. There is that. Okay, so some places do have that. You found the info in the patents of Bender. Well, that's interesting. Because there's you know, there are different isolation power systems. There's a bunch of different ones, but I'll tell you right now, it's one humongous, beautiful transformer down the bottom of the cabinet. There is no chopper drivers or anything like that. There's no rectification whatsoever. It's primaries in at probably 400 volts, something like that, and then your secondary outs. And your secondary outs, you know, after you it has to be a step down transformer. It has to be like the mains coming into that transformer are massive, and then the secondaries coming out going to your fuse panel are a wee bit smaller. And I would assume that it's a step down transformer. And the reason I would assume that is because you have all these operating rooms in a very close-knit area. It would make more sense to run in a higher voltage and step it down right outside the room. That way that section of the facility doesn't have a huge amount of amperage, you know, on the system. So I would assume that they have like 480 volt, and then they step it down to what they need at the isolation transformer. That's what I'm assuming, because it would electrically make sense. Yes, AK, you are exactly correct. It is so sensitive to EMF. You can see everything, and your EKG naturally has, in America, we have a 60 hertz filter on EKG. So if something comes through at 60 hertz, it will block it out. And actually, that's one of the tests that we can do on an EKG system, is we can see if the notch filter is working, which we will impose a sine of 60 hertz, and we'll see if it's nice and smooth coming out on the EKG trace. That is something that we can do. EEG, now EEG is just crazy. That EEG is the electrodes that you place around the skull, and the EEG will pick up everything. I mean, absolutely everything. I don't know if they have a 60 hertz notch filter. I would assume so, because, you know, we like using a lot of fluorescent lights here in America, and, you know, there's 60 hertz crap all over the place. So Parker's Connex on neighborhood equipment. Do you handle Cadwell? What do you mean by Cadwell? What do you call a Cadwell? I'm curious about this one, because I don't really know. Oh my gosh, guys, if you only knew. So I applied for yet another job today, and it's for a smaller facility, and it's closer to my house, which would, oh, it'd be so nice. But anyway, if I had got that job, I would be more capable of delivering better quality videos to you guys, because at a major medical facility like where I'm at, you should have seen my desk today. Oh my God. My phone just would not shut up. I mean, you guys heard it. My phone kept going off here, like here while I'm here. So it's just constant, guys. Throughout the day, I'm getting pinged. I've got my associates, my team members, they're coming up to me, asking me all sorts of questions. I'm helping people put stuff on record. I'm helping people correct their maintenance schedules. I've got customers I'm answering the phone for. I tell you what, I come home and I make these videos because this is my wind down time. Holy cow, days like today are just crazy. So if I go to a smaller facility, I'll hopefully have more energy at the end of the day to get some of this kind of stuff done. And man, one of these days I'm going to do a video about being turned down for jobs, because there's some really interesting reasons why people get turned down for jobs, and it's going to be really interesting, guys. So I've got a representative from Crothel. He is the lead. He's the lead recruiter for Biomeds in Crothel, and I've invited him to do a Zoom meeting with me. We're going to record it probably this week, hopefully this week. Hopefully him and I can get a schedule that matches up. And I have some really good questions I'm going to ask him about our career field. Like, what are they looking for in candidates? What type of candidates, you know, do they instantly know it's not going to work out? You know, what do you prefer in resumes? What sticks out to you? Stuff like that. I have, since he's the guy, he hires biomeds like crazy. Like, he knows what he's looking for, okay? And if I can get the answers from him, I can give those answers to you guys, and we will all be better off if we can figure out what the heck are these guys looking for. Sometimes they're not looking for anything, because sometimes the position is just a legal obligation. They post it even though they already know who they want for the position. but I'll go over that in another video because I have all sorts of stuff, man. Cadwell Labs EEG. You know, believe it or not, I do not work on any EEG. None. It's kind of crazy. Almost my entire career, I have been mainly around operating rooms, and I've got some CT. I went to a Philips CT course, and I've done several ultrasound schools and several patient monitoring schools and anesthesia school. But as far as like EEG, it's just one of those things I've never gotten into. They've always, if they can stick me in the operating rooms, that's where I'm gonna go, guaranteed. It's just the way it is. So I would love to go imaging. I was thinking today, guys, that what I'm currently doing is so boring. Guys, I love helping people and I love multitasking and I love the challenge of it and everything. But guys, I'm telling you right now, like I'm dealing with what CO2, end-tidal CO2 modules. I'm dealing with, you know, I installed the refrigerator today, which, you know, it's cool because I love my customers and I love working with them. But laboratories, guys, laboratories for me are not even a challenge, and I'm bored. I am excessively bored at work. It's busy. Don't get me wrong. It's not that I'm not busy. It's just it's boring work. Like I can train somebody else to do this stuff. Why? Why would they do that? So I would love to get into imaging, and we will see, man. Maybe my career is going to progress that way. I see that as the next big challenge. Can I make a video in the future about X-ray diagnostic imaging? Man, let me tell you something. I would love to make that video, and I had to make a decision earlier this week on where I'm going to go. Am I going to go to the ICE conference that's down in Florida? Why didn't I choose that one, right? But instead, I'm going to the conference in South Carolina this Friday. So I had to choose one or the other. You know, I'm way too busy at work to be taking off like two different events, which would be fun. But if I was there, that is the place for the latest and greatest diagnostic imaging technology, and it would be a perfect opportunity to make that video. And Benjamin, where were you last week, man? If you were to ask me that question last week, I would have not chose to go to South Carolina. I would have guaranteed chose to go to Florida. I think the flights were a lot cheaper too. But I don't know. You know, I kind of miss South Carolina, so gotta do what we gotta do. AK GE what? GE makes everything, man. I've done some GE patient monitoring training. I've done GE anesthesia school for the Avant CS2. GE imaging. That's pretty specific. A lot of hospitals, they go with one major vendor or another, and they get partnerships with them, and that's how they get major discounts. It's very rare for a hospital to have, like, you know, half their facility to be Siemens, part of it GE, part of it Toshiba or something like that. If it's a GE campus, they're going to have like GE. If it's Siemens, they're going to have Siemens. And if it's Philips, they're going to have a lot of Philips because they like those large, all-encompassing contracts. And you know, that's why they do it. They get some deals, and they have a good salesman that gives them kickbacks or something. I don't know. GE C-arms, AK. GE C-arms are the standard. The OEC, they are standard. And there's so many cool things I could show you guys about OEC. Unfortunately, I don't work on those. Again, that would be more of a challenge than what I'm currently working on. And just whatever reason, I don't know, man. It's like people see my resume and they see that like I've got a lot of operating room experience and other stuff, and I never get the chance. It's the craziest thing. Anyway, guys, I am gonna sign off. I wish I could have fixed this for you guys and showed you. That's a day in the life of repair, though. Let me tell you, you don't always win, right? Sometimes you got to say, it's not really worth it. It was already broke. I figured I'd bring it home. I'm going to show you guys how to open it up and how to goof around with it. I had to drill out some pop rivets. There's a lot of biomeds out there that are deathly afraid of drilling pop rivets. They think, oh, it's hermetically sealed and we can't service it. And it's like, guys, drill those little bastards out and get in there and see what's going on. But an ultra freezer, Kenny, what's an ultra freezer, man? I'm curious about this. What is an ultra freezer? Because I work with freezers all the time and I don't know this one. I'm curious what an ultra freezer is, because hell, maybe I'd like to make one. I've got, guys, if you knew the amount of electronics I've got, like here under my bench, stuff that I got over there, stuff over here, I got all sorts of stuff, man. And I mean, hell, I've got piles of stuff over here. I need to take some time and organize this. What? Cousin, what are you talking about, man? What are you talking about, beefing with Crothel? What incident are you referring to? There's always somebody that's going to call me out on my garbage. What beef are you referring to? Which time? Oh my gosh, guys. I've had some interesting run-ins. I wish I was at more liberty to speak with you guys on like all the details, but you know, in some ways I feel bad for Crothel. I really do, because I think that Crothel walked into some situations and they were a little bit led astray. But let this be a warning to all you guys. If you sign a multi-million-dollar contract, know all the details before you sign that damn thing, okay? Know all the details. You need, if anything, I'm telling you right now, Cousin, if they had somebody like me in there that came in before they signed the contract and said, here's what they provided for us, how do we make a bid on this job? I would go through this thing and I'd be like, you don't have enough information here. There's a lot of stuff you don't know. I would ask to walk the campus first. Can we please walk the campus? Because it's different if you have everything in one building versus like 10 buildings. 10 buildings require more people. They require more people. You can't have the same amount of biomeds for supposedly the same amount of equipment if it's in one building versus 10 buildings across an entire campus. It doesn't work that way. And I feel bad for Crothel in so many ways. There's some really good guys that work for Crothel. And my beef wasn't necessarily with Crothel, okay? Crothel has their own set of situation. They're a company, and they're chasing those beautiful government dollars. In order to chase those beautiful government dollars, they need to be ISO certified. And let me tell you something, as a biomed and as somebody that is being managed by Crothel, that just chaps my butt. It really does. ISO certification does nothing to help us whatsoever. You could do the same thing with reading a book and saying how to organize your shop, okay? It is such a pain in the butt, ISO certification. It creates so many delays on our side for when we got to order parts. If the vendor's not in the database, if they're not, if they don't have their W-9 start form through Crothel, then it's going to maybe take a week to order parts from them or something. Trust me, every one of my teammates, we've been down that road. We do know. So it's not that I'm saying something out of piece. But at the same time, Crothel has a network of people and they have a lot of capabilities, okay? So versus like an in-house shop that you don't have that many capabilities. Not saying that those capabilities have ever helped me out, but what I'm saying is like there's pluses and minuses to both sides of the fence. And I wish I could have warned the Crothel guys before they signed the line, because when I stepped foot on this campus, I noticed that some stuff was wrong. Some stuff was wrong, okay? I'm not going to say that this was happening, but I'll tell you as a matter of fact, when I showed up at this campus, let's see if I get called to HR for this, guys. When I showed up at this campus, there was a vendor that was managing, the same way that Crothel's managing us currently. And what happened was they had a spreadsheet basically, and that was our monthly PMs, okay? And what you had to do is you had to open up the tab for March or April or whatever, and as you did your PMs, you had to go to the database and you had to open a work order, create the work order, close the work order, to which you're probably going to do all that right there. The system we had before did not auto-generate PMs for every asset that it should have. So let's say you yourself on this magical spreadsheet, you were issued 100 PMs for this month. At the end of the month, you open 20 work orders, you close 20 work orders. Guess what? You're at 100%. 100%. Your numbers are magic. And guess what? We can kill your manpower because for years, you've been able to do this and you've gotten really good numbers. And all of a sudden now we have a database that kicks out work orders like a normal CMMS system. And all of a sudden they're like, oh, you guys, your numbers are horrible. Of course they're horrible. We have like half the amount of biomeds that we should have. Of course it's going to be horrible, guys. It's like we're running all around this campus. You're adding buildings without adding biomeds. I mean, trust me, we've been down some roads this last year. And so my beef is not necessarily with Crothall. All I'm saying is I am stressed out, guys. So when I'm talking about like maybe going to a smaller facility, it would be a little comforting. It would. Ah, man, you guys got me off on a tangent. I'm probably going to get called in and fired tomorrow for even saying this. Trust me, you think that's something. I got stories for days for stuff that I've seen. You need an ultra freezer that can go below 180 degrees centigrade to store liquid nitrogen and dry ice. Woo. Now, why do you ultra freezer is going to be used for reptile and amphibian DNA and snake venom storage? Are you thinking about starting up a Jurassic Park there, Kenny? Because I've seen this in Jurassic Park. So for that kind of temperatures, what you're going to be looking at is a liquid nitrogen freezer. And a liquid nitrogen freezer does not run off of electricity. It runs off of liquid nitrogen. And what it does is it auto-fills. I did a video on it, ultra lows. And every day it's going to auto-fill like a couple inches of liquid nitrogen from a large reservoir into the basin of this ultra low freezer. And it's just going to, naturally bubble off throughout the day. And every day it's going to fill itself back up. And you're going to lose about an inch to an inch and a half worth of liquid nitrogen per day, just naturally. Not a very cheap system to keep going because liquid nitrogen, it's what, $300 for a large receptacle of it, something like that. It's not cheap, but for DNA, yes, obviously you need to keep that stuff cold. Same thing with like bone samples and stuff like that. Yeah, just the same. It has to be kept real cold. But dang, guys. Oh man, I think everything that I wanted to talk about is pretty much covered. And the stuff that I do want to talk about before you guys get me talking about something that's going to get me fired tomorrow. I'm still going to get fired. They're going to talk to me tomorrow for sure. They're going to be like, guys, you can't be talking about our problems like that online. But I didn't mention who I work for. Guys, I didn't mention who I work for. And I've been doing my absolute best throughout this whole entire thing of keeping it from everybody of who I work for, because that way there I can say what I want to say, right? I mean, this is all real stuff. I can prove it. This is all true stuff, man. So TMS by Blue River. I've never heard of TMS by Blue River. Sounds interesting though. I want to do a video very soon about CMMS systems. That's the maintenance databases, and maybe compare a few of them, because you guys have heard me talk enough smack about my favorite company that maybe it would show you like an example of what I think a good one is. So if I can get several of them, maybe take some excerpts and give like a brief synopsis of what I think about it. It would have to be like a video series though to do a system real justice, because you have to like create assets in the database, You have to create work orders or see how it is to reschedule work orders for different months. It's, you know, in order to do a review on one of those CMMS systems, it would take a lot of time, man. It really would. But man, what a cool video, because there's some really cool systems out there. Some of them are mobile only solutions. So instead of like going to a computer, you have mobile only solutions, and you log in with your phone, you know, maybe with a thumbprint or something. You see your list of work orders. You do the work, you know, you can close it on your phone. You can Bluetooth keyboard to it if you need to. I mean, there's a lot of stuff that you could do from a phone or from a tablet. And unfortunately, a lot of the systems that I've seen are mediocre at best when it comes to like mobile. But we're mobile technicians, right? That's what we do. You would think mobile technology in 2021, they would focus their attention instead of doing more so to a desktop type environment with hundreds of clicks and options and stuff that you got to select, that they would simplify it. Do the Apple principle. Apple purposely makes their products simple and fewer options because that way there more people can use it. And it's not only got user friendly, but it has less problems because more stuff equals more bugs. And trust me, with the system that I currently have to use, I find bugs daily. All right. And the thing is, who can I report the bugs to? For the bugs that I have reported through whatever link is down below, it's not like they ever get back with me like, hey, we care about what you think or something. Nothing. So anyway, I'm thinking about doing a video series on CMMS systems. I thought about it for a while. I've reached out to some guys from like Dude Solutions and a couple other. I had a couple other guys that actually asked me, "Can you please do a review on our CMMS?" And I'll tell you what, considering how critical I am of some of these systems, that is pretty ballsy to say, "Hey, can you here's a link to our system. Can you mind giving us a review?" I actually appreciate that kind of attitude. All right, you got the balls to have somebody sit there and tell you how they think about your stuff publicly like this. It's probably a reasonably good product. So anyway, guys, thank you all for tuning in. I wish I could have got this fixed up for you, and in the end, it's cheap, it's inexpensive, and it was in the trash, so who cares? But I really would like to get an isolation transformer for the Biomed 1 that I'm working with now. And my Biomed 1 is helping me. She's going to help me. She doesn't know it yet. She's going to help me with some cool videos that I got coming up, because I want to see if I give like a brand new type of analyzer to a Biomed 1 with minimal instructions. I'm talking like 30 seconds, 1 minute worth of instructions. Can they figure it out? If they can figure it out, that's a win. That's a huge win for me, because I don't have to babysit them. And plus, a lot of the newer systems, a lot of the new analyzers and stuff, they walk you through the process of how to do the PMs. Can't ask for more, right? But guys, thank you very much for this. Stay tuned. I might have to, I might release one more video yet this week before I show up for the conference out there in South Carolina this Friday, and I'll have videos from there. But until then, I've got to pack my stuff and I got to get some stuff going over here before I can leave. So I hope to release one more before then, and hopefully it's a good one. Hopefully you guys like it. All right. Anyway, I'm going to sign off because my kids are out here. They're screaming. You know, they want me to go out and play with them. So thanks a lot again for watching, you guys. I do appreciate the support, and you guys are absolutely fantastic. All right. See you next time.